When you try to directly write a C language program to solve a particular problem or for a complex purpose, you might result in time wastage due to trial and error, improper algorithms, and ambiguous program flow. To prevent this, we can use pseudocode. Today we discuss about pseudocode and flowchart. A pseudocode is an informal high-level description of a computer program or algorithm. It is written in symbolic code which must be translated into a programming language before it can be executed. Pseudocode is an English-like representation of the logical steps it takes to solve a problem. Another way to represent a program is through the use of flowchart. Flowchart is simply a graphical representation of steps. It shows steps in sequential order and is widely used in presenting the flow of algorithms, workflow, or processes. A statement is defined as an instruction that directs the computer to perform a specific action. In each program that we have statements. So when writing pseudocode, we assume that the order of execution of the statements is from the top to the bottom. And this changes when using control structures, functions, and exception handling. Don't worry about these terms right now. We will study them one by one in our future lectures. Here is an example of pseudocode. Here you will see statements as statements 1, statement 2, and statement 3. They are between the start and stop terminals. Not only that we have statements, we also have mathematical operations in a pseudocode. Mathematical operations are integral to solution development, and they allow us to manipulate the values that we have stored. Here are some examples of mathematical operations and symbols that we can use. They can be categorized as assignment operators, comparison operators, arithmetic operators, and finally we have the logical operators. We also have keywords. And a keyword is a word that is reserved by a program because the word has a special meaning. Keywords can be commands or parameters. And every programming language has its own keywords or reserved words. Keywords cannot be used as variable names. And in pseudocode, they are used to indicate common input-output and processing operations. And they are written fully in upper cases. Examples of our keywords are the following. So we have the start, and this is the start of your pseudocode. The stop is the end of your pseudocode, and the input is the data retrieved from the user through typing or through an input device. We also have examples such as read and get, or read or get, and this input is used when reading the data from a file or a data file. We also have pseudocode such as print, display, and show, and this will show you your output to a screen or the relevant output device. We also have compute, calculate, and determine, which is used to calculate the result of an expression. The following are some of the examples, such as set and init, which is used to initialize values. Increment and decrement are used to increase and reduce the value of a variable. Now we have what we call conditionals. During algorithm development, we need statements which evaluate expressions and execute instructions depending on whether the expression evaluated to true or false. Some of the examples are the if-else statements. This is a conditional that is used to provide statements to be executed if a certain condition is met. And this also applies to multiple conditions and different variables. An example of the if statement or if conditional is given here. The yellow colored text here that are written in upper cases are all keywords such as if, then, and if. if is the start of the if conditional, and end if is the end of the end if conditional, and the then is the condition. Alright? So if you are happy is the condition, and then if you are happy, then you do this, such as smile, and then you end the if conditional. This is an example of an if conditional. This is another variation of the if conditional by adding more conditions such as if and else. So definitely it's not only an if conditional, but it is an if else conditional. So if you are happy, as the example was given here, then smile, then else you cry, and then end the if conditional. Another variation here is by adding more conditions. If you are happy, then smile, else if you are sad, cry, and else keep face plain, and then end if the conditional. Another conditional structure is the case structures, but they are used if we want to compare a single variable against several conditions. An example of case is given here. We have an input here. This denotes an input that the user will input a color. And then there's a case here of the color of the input. So if the user will input red, it will print red. If the user will choose green or will input green color, it will definitely print green. When it inputs blue, then it will print blue. Otherwise, if the user will input different colors rather than red, green, and blue, it will print please enter a value color, and then it will end the case. This is an example of a case structure. Now we also have iterations, and to iterate means to repeat a set of instructions in order to generate a sequence of outcomes. And we iterate so that we can achieve a certain goal. One example of iteration is the for structure. The for loop takes a group of elements and runs the code within the loop for each element. An example of for loop is given here, that this for keyword every month of a year or every month in a year, as long as it is the condition given here, it will try to compute the number of days for that particular month in a year, and then it will end. Okay, this is an example of a for loop. Now, similar to the for loop, the while loop is a way to repeat a block of code as long as predefined condition remains true. However, unlike the for loop, the while loop evaluates based on how long the condition will remain true. This is an example. So we have a precondition which the variable x is set to 1 or equal to 1. So as long as the population is less than the limit, it will continue to compute the population as this formula, population plus births minus the deaths. So as long as this condition is met, it will continue to execute the following statement. However, if the while condition becomes false, it will end the while condition. Alright? So to avoid a scenario where our while loop runs infinitely, we add an operation to manipulate the value within each iteration. And this can be done through an increment or a decrement as such. Now, flowcharting is a tool developed in the computer industry for showing the steps involved in a process. A flowchart is a diagram made up of boxes, diamonds, and other shapes and connected by arrows. And each shape represents a step in the process, and the arrows show the order in which they occur. Flowcharting combines symbols and flow lines to show figuratively the operation of an algorithm. there are 6 basic symbols commonly used in flowcharting of a particular programming language. And they are the terminal, the process, the input and the output, the decision, the connector, and the predefined process. This is not a complete list of all the possible flowcharting symbols, but they are the ones used most often in the structure of any programming language. We have here as an example of the terminal. The terminal is shaped like an oval with a label inside such as start or stop, because it indicates the start and the end of the program, a process, or interrupt program. We also have the symbol input and output. It is denoted by a slant rectangle. It is used for any input or output operation, and it indicates that the computer is to obtain data or output results. We also have the process. The process is a rectangle given by the label inside the name of the process, and it indicates any type of internal operation inside the processor or memory. We see a different kind of process with lines here on the sides, and it is used to invoke subroutine or an interrupt program, and they are called predefined process. Another symbol is the decision, and it's shaped like a diamond, and it's used to ask a question that can be answered by yes or no, or true or false. And then we have the connector. The connector is used to connect one flowchart to another one, and it allows the flowchart to be drawn without intersecting lines or without a reverse flow. Finally, we have the flow lines. The flow lines are just typical lines with arrowheads, and it shows the directions of the flow. Now here we have example of a pseudocode. In between the statements are the start and stop terminals. So we have the following statements such as input. Definitely it's an input. And then there's a variable called my number. Another statement is to set my answer will be equal to my number multiplied by 2. And the output will be set to my answer. Now how do we translate the following into a flowchart? So we can translate that the start will be given as the start symbol, and then input will be translated as an input symbol in a flowchart. And then this statement set is a process. It's not an input. Definitely it's a process. It's telling that we have to set my answer will be equal to my number multiplied by 2. And then we have an output symbol here. Output my answer, and then the terminal stop is given here. Now we have general rules for flowcharting. Before you can make your flowchart, you have to remember all the symbols, definitely. However, there are general rules for flowcharting, such as remember that all boxes of the flowchart are connected with arrows and not lines. Flowchart symbols have an entry point on the top of the symbol with no other entry points. And the exit point for all flowchart symbols is on the bottom, except for the decision symbol. The decision symbol has 2 exit points, and this can be on the sides or the bottom and one side. We will give some examples of that later on. Generally, a flowchart will flow from the top to the bottom. However, an upward flow can be shown as long as it does not exceed 3 symbols. Other rules such as connectors are used to connect breaks in the flowchart. Examples are from one page to another, from the bottom of the page to the top of the same page, and upward flow of more than 3 symbols. Remember that subroutines and interrupt programs have their own and independent flowcharts. So all flowcharts start with a terminal or predefined process for interrupt programs or subroutine symbol. And all flowchart ends with a terminal or a continuous loop.